Welcome back, viewers, to the 7th lecture of this online series of lectures on Introduction to Category Theory. So we proved one proposition in the last segment. In this segment, I am first going to introduce the notion of subobject classifier and characteristic function. Okay, let's get started with subobject classifier. Subobject classifier for the category of sets is just a set along with a particular function. Let me define it first. So the topic is subobject classifier. And characteristic function. Characteristic function. Okay. Only for the category of sets, of course. Okay. We're not talking in general in the context of the category of sets. So definition. Define the subobject classifier for set denoted by omega to be the set omega equal to a two-element set, okay? True or false. So omega, the subobject classifier for the category of set, is just a set with two elements in it. One is true, another one is false. Together with the function, it is equipped with the function. Together with the function so there is a singleton with the unique object as the smiley, and that gets mapped to the true of this subobject classifier. Okay, so this guy gets always mapped to the true element of this subobject classifier, sending the unique element to true. Sending the unique element to true. This is the notion of subobject classifier. Okay, so now I'm going to state a very important proposition on how to relate a power set of a given set with subobject classifier associated with that set. Okay, so let's do it. Let me state it first, and then I'm going to prove it. Proposition 2. Let B be a set there is an isomorphism. There is an isomorphism between all set B to omega. Omega is that two-element set that we have already defined as a subobject classifier, the subobject classifier for the category of sets, and this power set of B. What is this power set? Let me recall from the second lecture that this guy is nothing but the collection of all the subsets of B. Okay? So if you have a set B, then the power set of B is the collection of all subsets of that set B. So it's a set where the elements are also set. claim is that this is an isomorphism, and we claim this function to be our isomorphism. Okay? So we are going to define phi appropriately. So let's go along the proof. Given a function f from b to omega, b is a given set, okay? Omega is the two element set, okay? And that is f is an element of the Hom set from b to omega. So we chose an element from the domain of this function phi. Let. So I'm going to define this function now. This map between the map between these two objects. One is Hom set from b to omega, and the other one is the power set of b. So Tf is defined as all the elements from B. We choose the elements of B for which f of B is going to be true, okay? Because this f of B, f acting on an element of B can be true or false. We want only those B's on which acting f will just be true. Okay? F of B is equal to true. So what is phi of f? Phi of f is we can see immediately that this is a subset of the original set B. Okay, by construction. Now construct. So this is the function. This is the definition of this function phi. Now we want to construct the inverse of this guy, so that we can prove that this is indeed an isomorphism. So how do we construct that function? Now construct a function. Excuse me. A function psi from the power set of B to the Hom set from B to omega. Alright? So we want to construct an inverse of this guy. So this guy, the codomain will be now the domain of this new function. The codomain of phi will now be the domain of this new function psi. And well, we need to define psi as well. We construct a function psi to serve as the inverse of phi. Inverse of phi. Okay? Okay. So it needs to be constructed. So we choose a subset of B first. Let B prime be a subset of B. We need to define this. So this is exactly the characteristic function associated with a subset of B, as we will see later. For the moment we are going to denote it by psi, but later we'll give a new notation for this particular function. Okay? So let's stick to this notation of psi for the moment, for the time being. Then psi of B prime is expected to be, this is a subset. So this is the collection of all the subsets of B. So we could take an element from there, which is B prime. Okay? B prime is an element of this power set. So observe that B prime is an element of this power set of B. Okay, since B prime is a subset of B. So this is an element from the domain of this the math psi, and after the action of psi on E, we expect it to be an element here in this Hom set, right? So psi B prime. So psi acting on B prime will be an element here. In other words, it will be a map from B to omega. And this guy is defined as exactly the same way we define the characteristic function, which we'll do later. So psi B prime. So we have to be given this subset a priori, okay? And given that subset, we can construct this function psi associated with that subset, which after acting on B will either spit out true or false, depending on if B is in B prime or not, respectively. So it tells you that this map acting on B will spit out true only if B is in B prime, and it will give false if B is not in B prime. This is how we define this function. Okay. Now, the claim is that the psi, the way we define psi is indeed gives us an inverse of the function that we had in the first place. So let's try to prove that this is indeed an inverse. Now let us first prove that. Let us first prove that psi coupled with phi is an identity map on the Hom set from B to omega. Okay, this is the first step of proving that proving the fact that phi is indeed the inverse of psi. Okay. Okay. Given. Okay. First of all, I need to see. It takes what to what. Okay. Psi composed with phi is a map from Hom set B, omega to itself. Check that. It's obvious from the definition of psi and phi. Okay. So in order to express it and show that, this is indeed the identity map of this Hom set, we have to pick up an element from this Hom set first. Let us do that. Given f in the Hom set from B to omega, that is f is a map from B to omega. So psi composed with phi, okay, acting on f. Where does this guy live in? This guy lives again in the same Hom set, okay? Because this is the map from the Hom set to itself. So f is an element of the Hom set, so this guy will also be in the same Hom set. Okay, so since this is in the Hom set, the whole thing is in this Hom set, therefore this is the function from B to omega, therefore it will act on an element of this B in the following way, right? By the concept of composition, we see that This is precisely this thing. And by the definition of the function psi that we have done here, see that phi of f is a subset of B, the original set B. The way we defined phi in the beginning. So this is going to be true by using this definition here if B is in phi of f. It's false if B is not in phi of f. Okay? Now, I want you to check the definition of phi. Okay? Let me rewrite it here for you. I don't need it anymore. Probably if I need, then I'll write it again. And I need space to complete the proof. So let me rewrite the definition of phi of f here, which I erased during the course of the proof. Phi of f was defined as a subset of capital B this way, which we saw that is indeed a subset of this set B. Okay? So now, using this definition, see immediately that if B is in phi of f, then this fact is equivalent to the fact that FB is true. Okay? This is obvious from the definition. So now, this allows me to write it in this way. This allows me to rewrite it in this way. So let me erase these two parts. This is true, and which is equal to precisely FB. Right? If B is in phi of f, so this guy is equivalent to that. This statement, the statement on the left is equivalent to the statement on the right. So if I negate one of the statements, the other will be negated as well. Okay? So if FB is false, it means that B is not in phi of f. So is FB is false if B is not in phi of f. Okay? This follows from this definition. Okay? All right. So what did we get? We got that psi composed with phi psi composed with phi acting on B is equal to precisely f of B for all B in B. Okay? Which means that psi composed with f of B is indeed, psi composed with phi is indeed the identity element of this concept. On set B comma omega. So we prove this part. Okay. Now, for the other part of the proof, we proceed as follows. Now we want to do so what is phi composed with psi? This is going to be a map from the power set of B to itself. Check it. It's obvious from the definition of phi and psi. Okay. Now we want to prove that phi composed with psi is the identity map on the power set of B. Okay. Alright, so choose an element of the power set. Since psi is a map from the power set of B to the Horn set from B to omega, okay, by definition. Psi of, well, when we expect psi of B prime to be, psi of B prime is expected to be in this Horn set. Okay? And well, by definition, as provided earlier, phi of psi of B prime, well, so we invoke the definition of phi is equal to OB in B such that psi of B prime acting on B is true. Right? So this is what we have according to the definition of phi. But observe that from definition of psi, we know that psi of B prime, let me write it again because I erased it, to create space for the rest of the proof. If B is in B prime, if B is not in B prime. Okay? So this was the definition of psi associated with this subset or an element of the power set of B. So B, you can consider B prime to be a subset of B or B prime to be an element of the power set of B. And so let's keep going. And another thing to notice is that from the definition here, that psi acting on B prime evaluated at B is true if and only if B is in B prime. This follows from this. This follows from this definition, right? This definition. Observe that. So this guy, right? So combining this with this, we see that this holds. Okay, psi of B prime acting on B is true if B is in B prime. I think I don't need that part of the definition. It just follows from here. See that? So you just take the first one. Okay, you don't need the later one, and then negate the first one, or the right side of the first one. You'll have the fact that psi of B prime acting on B is true if B is in B prime. Okay? Well, then you negate it, then you see that B is not in B prime. That will imply that psi of B prime acting on B is false. Okay? So it actually follows from this one. This implies this. Okay, good. So it gives me. So now, using the definition of psi, I have seen that this holds, and this will conclude that B this is equal to this is equal to exactly the subset of B prime. Okay? We only have those elements from B such that they are also in B prime. Okay? So it means that we thus have phi composed with psi acting on B prime is equal to B prime. Establishing the fact that phi composed with psi is indeed the identity map on the Hom set on this power set B. Okay. This completes the proof. Okay, so we'll start from the characteristic functions in the next segment. Okay, thank you very much.